Hey everyone, this is John at Digital Scepter. We're going to wait a minute or two for all the attendees to hop on. Looks like there's 15 so far. Okay, let's get started. My name is John. This is a customer, Falco customer focused webinar, meaning we're going to talk about a feature on the firewall that is a latent feature that is, doesn't cost anything extra, but it adds a lot of value if you turn it on. So we wanted our Falco customers to get it all turned on. We put this together to motivate you to enable it. If you are a Falco customer, you can use your ticket entitlement to get it scheduled, and we'll help you out. For anyone else that might be joining, Falco is our custom firewall configuration monitoring service. We will send a weekly report with findings about the firewall, give you a to-do list to improve the settings. You can use our help desk to help improve the settings. If any issue arises, you can use our help desk. That being said, if hopefully this information in here will help you just set it up on your own if that's the best way forward for you. Feel free to type in your questions in the Q&A. The presentation will be 15-20 minutes. After that, we can dive deeper if you have any questions. It is being recorded in it's set up right now in 2 days to send out the slides and the recording for anyone that wants to share it or watch it later. And I think pretty much everyone on here knows Coleman and Zach. So without further ado, I will turn it over to Coleman.
All right. So what we're going to be talking about is TLS inbound inspection, as Palo Alto likes to call it. So if you guys have used outbound decrypt, it's like that, but better and easier. So let's start off with a little bit of motivation for why we need decryption. And there's lots of things to say on this topic, but I thought an example would probably be a little bit more illustrative. So here's an example of what your firewall sees if you don't have decryption, right? This is a standard TLS stream. There's some information in here. The request example here isn't using TLS ESNI, so there could be even less information. We can maybe see it's going to example.com, not a whole lot. However, with decryption, we can see everything about the session. We know exactly what's happening, all the data, all the information, and there's something else in here. I don't know if any of you have spotted it yet, but there's a vulnerability in this connection. There's a SQL injection attack in here. So that's really all it takes. If you weren't inspecting this and your application wasn't built with mitigating these kinds of attacks in mind, that would have been it. And you guys would have lost a lot of data if they had figured out your schema there. So that's the reason why we want to do decryption, right? We want to see into all these streams, not just for threats, but also for enforcement for things like URL filtering. So the firewalls have two main ways to do decryption. There's forward proxy and inbound inspection. The forward proxy, as you guys are probably familiar with, that's what I like to call outbound decrypt, because forward proxy is a little bit more confusing. In that setup, you have your users behind the firewall going out to external servers. So in that case, what we do, we have a certificate authority installed on the user's machines. The firewall man in the middle is the session. We get all the visibility. For inbound inspection, it's very similar, but in reverse. So we've got external users, and those don't need to be users. They could be other servers as well, but they're coming through the firewall to your internal servers. So that kind of minor difference really affects the way it's set up and how easy it is to maintain. So let's go right into a comparison of the two. With outbound, like I mentioned, and you guys are probably aware of if you set it up, you need that CA cert installed on all your devices. They need to trust that CA cert so you can man in the middle of them. On inbound, you only need the certs for the servers you want to decrypt on the firewall. Outbound decrypt is pretty much a constant game of whack-a-mole. More and more services are moving to pin certs or using things like Quick or other protocols that we can't decrypt. So it's a lot of effort to stay on top of. It's not something you can just configure and let it run. Inbound decrypt is pretty much the opposite. You configure it, and the only updates you'll really have to do are updating the certificates, renewing your certs, or updating Cypher versions. The other problem with outbound is that, like I said, not all the traffic can actually be decrypted. You can't decrypt devices that you don't control. So if you've got, guest networks or devices that you don't manage, you really don't have that ability to decrypt them. Whereas with inbound, anything that you control, any server you control, you can decrypt, and you only need control of the server side. So it's a lot easier. But probably, I think the biggest deal with outbound versus inbound is the return on investment, right? Outbound's a lot of work, and what you get from it is the ability to see user traffic going out. So that helps you protect users from themselves, but most of your threats are going to be coming from the outside. Now you'll get the occasional user compromises their own machine, and then a attacker pivots from there to go somewhere else. But all of your servers that have public facing IPs or are NATed are constantly getting hit with attacks. If you've ever looked into the threat logs, you've seen those on the firewall. So inbound really has a great ROI because it's explicitly aimed at protecting those servers from outside attacks. So with that all said, I think there's a very great use case for setting up inbound. It's a lot easier. I'd say you could do it in an afternoon if you had everything. So let's dive into a little bit of how it works, some of the lower level details, and then we'll get to a plan to implement it. So at the low level, essentially what's happening is you load that certificate on the firewall. So that's the same certificate that your internal servers would be using. And then when the outside users create a TLS session to the internal server, the firewall intercepts it, terminates the TLS session, inspects all the traffic, and creates a second TLS session going back to the internal server. So from both sides' perspective, nothing has changed, and there's very minimal. There's a very minimal footprint here, so you don't have to change any settings on the server side. All you have to do is load that certificate and configure it on the firewall. That being said, here's all the requirements that we've got. So we've got to have valid public certs for the servers we want to intercept. Technically, that doesn't need to be public certificates because it's got to be trusted by whoever's sessions you're going to intercept. So that you could do this within a fully internal CA and everything. as long as the client's trusted that CA, of course. You also need a little bit of an understanding of the TLS versions and ciphers you've got in your environment. We'll go over that in just a moment. And the last thing is you can't use client cert-based authentication. So some of you might know that by the name MTLS, mutual TLS. That's where instead of the server, you typically connect to a TLS server. They validate the connection using the cert that the server presents. There's a mode in TLS where both sides can validate each other using certificates. So that isn't supported with inbound inspection. If you have that in your environment, it's not compatible currently. Although it's pretty rare. I think I've only seen it in a handful of cases, and it's not really the kind of thing you'd want to be doing inbound inspection on anyways. So with that all said, here's the basic project plan to get inbound inspect going. There's a lot of points on here, but they're all fairly easy. The first thing is before you start, you want to make sure that all of your firewalls that are going to be doing any of the decrypting, even if they were just doing outbound inspection, I would recommend this as well. Make sure you're on PAN-OS 10.0 or greater. There were a lot of changes to the decrypt settings. They can do TLS 1.3 now, and there's a nice new set of tools for troubleshooting if anything goes wrong. So that's very useful. Then the next step is to get a list of all the services you want to decrypt, right? Figure out everything that you have control over, everything that is, high priority. You'd want to spend the time to make sure that you can inspect that traffic. Then you need to identify if you've got any special requirements for TLS versions or ciphers. So this is getting less and less common, but older appliances or older servers, stuff that's legacy and you're just waiting until you can replace it with something else, you may need to support some older TLS versions or ciphers. So identify any of those ahead of time. That way you can configure your cipher suites accordingly. And then after that, all you have to do is gather all those certificates. So I recommend typically a wildcard because it makes this easier. That way you don't have to have a cert per, and renewals are easier. But there are trade-offs with a wildcard, of course. And then at that point, all we have to do is import the certs into the firewall, create a decrypt profile, create some decrypt rules to decrypt the connections to those services, and then validate that everything's working like we expect. So the prep really takes the most time. Actually configuring it on the firewall, you could do in 15 minutes. So let's look at a sample decryption profile here. So if you guys have never set up a decrypt profile before, this is where you control all the settings for decrypt. The second tab here under SSL decryption, that's the first tab. The second level tab, SSL inbound inspection, is where you can configure the inbound related options. So that's these guys right here. So those two are kind of important. They basically enforce the protocol settings we'll set on the next tab. So block sessions with unsupported versions does exactly what it says. If the version isn't in the list you've configured, it'll block it. And the same thing with the cipher suites. There are underneath here the failure checks. Those are a little bit more nuanced. I won't go into those right now, but it's safe to leave those off for right now. So with that said, before we get into all of our options for our TLS or for our protocol settings here, we need to talk a little bit about the details on what we're actually configuring. So a TLS connection involves both the client and the server agreeing on some details for 3 different algorithms. You've got the key exchange algorithm. That's what actually allows the peers to determine a shared secret key. You have the encryption algorithm. That's what actually does the encrypting, right? To make sure that nobody in the middle can snoop on your data. And then the authentication is to make sure that none of that data has been tampered with. So each of these algorithms has a lot of options. There's different algorithms and different options for each of those algorithms, for each of those there. So the trouble with that is that most of these are insecure. This has been a problem for a little while now, but effectively it's gotten so bad that future TLS versions are just straight up removing a lot of the options. So that way you won't have the ability to configure these incorrectly, because there will only be sane correct defaults. So let's take a look. And this is stuff you definitely don't need to know, but it's an interesting thing to see. So these are all of the key exchange algorithms that were supported in the various versions of TLS. As you can see, 1.0, 1.1, and 1.2 supported a ton of different key exchange algorithms. But when we get to 1.3, there's only a handful that are allowed. And those are the ones that all support forward secrecy. So the same thing here we'll see with our cipher selection. So this is the encryption algorithm itself. The secure versions are kind of few and far between. There's a lot of these versions that are definitely not secure. In 1.3, the only options you have are secure. So that's kind of, you're going to see that as well here on the data integrity section. 1.3 is kind of the way to go. If you can do it, you should. As for if you can do it, here is a overview of the adoption of TLS 1.3. So across all the different browsers, and this is shown with the size of the usage of each browser here. Across all the different browsers, we've got about 90% of internet users support TLS 1.3. So the rest of those, you're talking about IE11 clients, kind of other weird embedded browsers, those kinds of things. So you can safely turn on TLS 1.3 for just about everything. And if you had a client who couldn't connect, you could, maybe make an exception for them, or in all likelihood, you'd probably want to tell them to upgrade to something a little bit more secure. So with those details, let's actually look at how to configure a decrypt profile. So this is the next tab, that SSL protocol settings tab. And we've got the first thing we're going to do is look at the protocol versions. And I've got a nice little breakdown here of when each of these versions was standardized and which one is secure. So 1.2 is okay as long as you've got good selections on the rest of your options, and we will in this slide as well. So you could do 1.2 as the minimum, and then if you leave it with max as the max version, that'll have 1.3, or if there was a future 1.4 added, that would be supported as well. So we'll go through these a little bit faster because it's a little bit repetitive with the past slides, but essentially for our key exchange, you want to be doing Diffie-Hellman. RSA is okay. It's not the best, but it's okay for right now. Note that if you're doing just 1.3, that'll be disabled. In TLS 1.3, you can only do Diffie-Hellman. Now for our encryption algorithms, 3DES and RC4 are definitely insecure. You should not be using those anywhere. AES CBC is okay. AES GCM is better. Cha-Cha 20 Poly 1305 is best. That's a TLS 1.3 standard as well. And lastly, for authentication, as long as you're not using MD5 or SHA-1, you're okay. SHA-384 is the best. So with that out of the way, oh, and by the way, I think John mentioned this, but if you're looking at this and going, crap, I'm not going to remember these, don't worry. We'll send out all the slides afterwards. So you definitely don't have to memorize these guys. So then the last thing to do is set up your decryption policy rule. I glossed over the first couple tabs here because it's basically like every other rule you've created in the firewall. You set a source, a destination, a service, or a URL category. And then the important things here on the options tab are that we want to set this to decrypt. We want to use SSL inbound inspection. And then you provide the certificates you're going to decrypt the connections with, and then the decryption profile that governs those connections. Down there at the bottom, the log settings, those are fine by default. If you have a log forwarding server, like a syslog, you'd want to select it there under the log forwarding profile. With that all said, once you've got that configured, this is what you'll see. So if you're looking at your traffic, you'll see here we've got some inside traffic going to one of our servers, and you can see the decrypted column is yes. So all this stuff is being decrypted on the inside. And then if you're looking at the detailed log view, there's a section in the flags that'll show it's decrypted. So
And you'll actually see the application that's running inside the encryption.
yeah, good point. So you'll see on the if we go back a slide here, you'll see that the application isn't just SSL, it's GitHub base or it's WebSocket or Git base. So without that, you don't always see the application. Some applications can be figured out without decrypting, but most of them can't be.
Yeah, in this case, like I know that was showing GitHub, that was actually a private GitHub enterprise server. So when you can get app ID information, it's generally via certificate. Since this is a certificate issued, I know you guys don't see this, but this is a certificate issued from an internal private CA. There would be no way Palo could determine the app. So it's recognizing it from just traffic signatures.
All right. So the final thing we wanted to talk about was some troubleshooting hints. If you've ever troubleshooted outbound decrypt, it's very similar. In fact, most of your issues are the same between both. You're going to want to use the new decryption log tab. So that's under monitor logs decryption if you're on a PanOS version 10.0 or higher. If you're on a lower version, you won't have that. There's still some ways to troubleshoot it here. But mostly you'll want to use that log tab and look at the error and the error index columns. Those will basically tell you exactly what went wrong with the connection. It'll tell you the category. So it'll say, oh, the issue was certificate, and the specific issue was the certificate was not trusted by the client. And that's, a pretty dead giveaway of what's going on. For inbound inspection, you're most likely to have an incompatibility with the TLS versions or the Cypher suites that you've enabled. If you do have an issue with that, that's pretty easy to fix. You can configure them on the firewall. You could also see, like I mentioned earlier, certificate errors, although those are less likely with inbound, as long as you've loaded the right certificate. And then past that, if you can't figure it out from just those, you can reach into the packet captures and the hardware counters. So if you guys have done any troubleshooting with Zachary before, our favorite command in the whole world is show counter global filter packet filter yes delta yes. That will show you all of the hardware and software counters that have changed since you last ran the command, and using your packet filtering settings to narrow down the traffic so you're not looking at everything all at once. So with that, you'll be able to see the counters for the specific decrypt reason, the decrypt failure reason. That's very helpful. All right. I think that's it for the setup. It's a fairly easy setup. Like I said, if you guys have all the requirements and you've got a plan in place, you could definitely do it in an afternoon. I know several customers who we've decided to set it up and then set it up all in one meeting. So it's not very hard to configure at all. So does anybody have any questions? All right.
I don't see any questions typed in anywhere, and I don't know how to let everyone talk right now. So, oh, there's one.
From William.
10 or 10
or
1 if you're on
10-1.
9-1 already.
Yeah. So this, and Zach, you might want to chime in. You might have more 10-1 experience than I do. If you're on 10.0 right now, you're okay. until I think the end of life, the end of life for 10.0 is I think in June.
I think it's July 16th.
Yeah. So the end of life is in July, which is coming up. So ideally before then, everybody would be upgraded. 10.1 did have some issues early on. So if you're on 9.1, I would get on 10.0. You're going to have to go through 10.0. I would get on 10.0 pretty soon. And then hopefully by the time we're, a few months out from the end of life, there's a nice, very stable version of 10.1. As with everything, it's always how many features do you have turned on? The more features you've got, the more likely you are to run into an issue. If it's a fairly simple firewall setup, you're not doing anything complicated, then you should be good going to 10.1.
Another question is, how would this compare to a WAF? Well, it does compare pretty well. I'm sure that this could be actually a pretty deep topic, but if you, for example, went into the vulnerability profile and typed in like SQL or Apache or something like that, there are a ton of protections against web application attacks. Now they're signature based, so if you really get into the philosophy of what a web app firewall would be, if you wanted it to be the best web app firewall, it would also be a very labor intensive firewall, because you'd want to whitelist all of the requests that your app can allow. So the web app firewall only would be a positive security model at that point. So like your Imperva or F5 would have to have a list of every single allowed request. So then you don't care what anyone else tries, it's all going to be blocked. So when I think of web app firewall, that's what I think of. But in practice though, most of the time people will put a web app firewall in front, and it's just protecting all of the low hanging SQL injections and buffer overflows and things like that. So yeah, I would say that this is a way to implement the Palo Alto firewall as a web app firewall. With the caveat that there might be some gaps. I haven't fully explored all the gaps lately, but yeah, it's a latent web app firewall that's sitting there ready for you to use.
And the other thing to mention too is that we've been talking about mostly the context of web servers. Technically, anything doing TLS, you can put this in front of. So it doesn't necessarily have to be a web server. So it's a little bit, it's got a little bit more features than a WAF in that sense. It's not just speaking HTTP.
Another point to mention is like with a WAF, like you put something like an F5 in, and SSL, well, it's referred to as like SSL offload in that case, but it's almost always done on an F5. Certs get installed and that traffic is inspected. And so a WAF can often be regarded as good at getting that application control. And it's really just because people are going through the process of getting the certs installed and doing that SSL inspection. And you can do that on a WAF and on the firewall. They're not like mutually exclusive. You can do it on both and in both places. And while a lot of the functionality does overlap, there are differences. Kind of to John's point, it's a deeper conversation to have there. But if you just go through the process of getting the cert on the PAN also, you get a lot of the benefit that you'd get from a WAF.
Yeah, good point. There's another question too about maintaining outbound decrypt. We were contrasting the features. We don't, this doesn't replace outbound decryption or forward proxy decryption, and should definitely get that implemented as well. We'll probably do that as a separate webinar. We've done that in the past, and we'll probably do another one.
Looks like we had another question about doing decryption as if you're a vSys tenant. So I'm trying to think, I think everything on the decrypt side can be done by vSys admins. So you guys should be able to do it definitely for inbound inspection. There's nothing that would require you to even go to the network or device tabs, except
the cert upload.
Yeah, that's the only thing you need. So once you've got the certs on the firewall, the rest of it, the decryption profiles, the decryption rules, all of that is all done just through your normal rule bases and objects. So you guys could definitely get it set up. And if you're working with one of the COEs that we've been working with pretty closely, then that's definitely on the radar of things to do. I've got another question about testing decrypt before turning it on. So this is one of the cool things, because those decrypt rules, and well, I could pull it up, but you guys know what the rules look like. They're essentially, you can say the source and the destination. So one of the things you can do is say, hey, let's do inbound inspection. We're setting it up, but only for this particular public IP. And then you can test it from an external or internal, depending on how you've got it set up. You can test it without decrypting everybody coming in, and that way you can shake out those issues. Like I said, if you understand the TLS protocol and cipher requirements, you shouldn't have very many issues turning it on. The setup would be, or the issue you could have if you enabled it with incorrect settings, you could have older clients not support the connection, but you would be able to fairly quickly change it. So if you did it for a major service, I definitely recommend flipping it on during a maintenance window. Have as many stakeholders as you can in that call, and have them test their respective services. That's usually the best way to validate that everything's working as intended.
There's another question in the chat. When building the rule with a NATed IP, do you use the public or private IP of the server?
That's a good question. I believe the rule would match the post-NAT zone and the pre-NAT IP.
Yeah, that's correct.
Yeah. So NAT is always done very late in the stage on the firewall. So the security rules are all processed, and the NAT is basically done right before the packet is forwarded out the correct interface. So the thing that does change is that the zone will be looked up based on the potential NAT match. That way the zones, the destination zones are correct. So once again, that'd be post-NAT destination zone and pre-NAT destination IP is how you would match it. Your sources will be identical.
All right, I think that about does it. If anyone has any questions later, go ahead and send us an email. If you are a Falco customer and you want to get this set up, please email support and we'll get it scheduled. All right, great. Have a great day.